Okay, I'm going to try and stream today because the internet connection seems to be doing a little bit better and it's not dropping frames the way it was yesterday. So yesterday I did not manage to record a video of the day's problem for various reasons anyway, but there is none. But hopefully I'll be able to record one today and the problem will start in just 1 minute. And as always, super tired, so hopefully this isn't too bad, because if it is, then it will be bad. Yeah. And okay, that seems to be working, so that's good. Let's get to this thing, and let's get to this thing. And it is day 10. You can see that I have the 2 stars for day 9 because I did them, but you'll never see the video because I did them off video because it was too frustrating, and also my internet connection was not cooperating. So, but luckily I have a good internet connection today, and so hopefully things will go smooth, and hopefully this doesn't use the stupid encode computer because I'm sick of the encode computer. Monitoring station. If flying the asteroid belt, reach the Sirius monitoring station. They'll hear of an emergency. They're having trouble tracking all the asteroids and can't be sure they're safe. So I'd like to build you a new monitoring station near your space, and you a map of all the asteroids, your puzzle input. Map indicates whether your position is aimed or contains an asteroid. The asteroids are much smaller than they appear on the map. Each asteroid is exactly in the center of its marked position. The asteroids can drive with x, y coordinates, where x is the distance from the left edge, y is the distance from the top edge. So the top left corner is 0, 0. The position immediately to its right is 1, 0. Your job is to figure out which asteroid would be the best place to build a new monitoring station. Monitoring station can detect any asteroid to which it has a direct line of sight. That cannot be another asteroid exactly between them. So line of sight can be at any angle, not just lines aligned to the grid or diagonally. The best location is the asteroid that can detect the largest number of other asteroids. For example, considering the following map. The best location for a new monitoring station on this map is a highlight asteroid at 3, 4, because it can detect 8 asteroids more than any other location. The only asteroid it cannot detect is the one at 1, 0. Its view of this asteroid is blocked by the asteroid at 2, 2. All other asteroids are worse locations. They can detect 7 or fewer other asteroids. Here's the number of other asteroids a monitoring station on each asteroid could detect. Here's an asteroid and examples of the ways its line of sight might be blocked. If there were another asteroid at the location of a capital letter, locations were marked with the corresponding lowercase letter would be blocked and could not be detected. Here's some larger examples. Best is 5, 8 with 33 other asteroids detected. Best is 1, 2 with 35 other asteroids detected. Best is 6, 3 with 41 other asteroids detected. Best is 11, 13 with 210 other asteroids detected. Find the best location for a monitoring station. How many other asteroids can be detected from that location? Okay, so I don't actually care about the grid. From type being import list and dict, let's say. And so let's just say class asteroid named tuple. This is a little bit frivolous, but we'll say x int y int. And now what we want to do is we want to say asteroids is just going to be a list of asteroid. And what we want to do is count the visible ones. And so here is the key observation that I sort of made up while I was reading this problem, which is that if I pick something to be the center, I rewrite all the coordinates in terms of that, and then I basically just look at equivalence classes of slopes. And for each equivalence class of slopes, count visible asteroids from I don't want to call it so let me call station, which is an asteroid. It's going to turn an int. So what I'm going to do is I'm going to rescale not rescale, rescale is the wrong word, but I'm going to recenter and say that asteroids equals for x, y in asteroids. So x minus station dot x, y minus station dot y, and I'll make that an asteroid. So I'm basically going to say, you know, if I'm observing from the asteroid that's at 3,3, then I'm going to subtract 3 off so that the guy at 4,3 is now at 1,1. And what I want to do is I want to do slopes is going to be a set, and I'm slightly worried about floating point issues here, so I'm going to not worry about them now. And for asteroid in asteroids, and let me even do this, x, y in asteroids, dx equals x minus asteroid dot x, dy equals y minus asteroid dot y. If dx equals dy equals 0, pass. Otherwise, if dy equals 0, slopes dot add float infinity, and let me just make sure CD date 10, and what I want to check is like 6 divided by 5 equals 12 divided by 10. True. Okay, so that should be fine. And this should be station.x and station.y. So this is just because I don't want to divide by 0. And then otherwise, slopes.add rise over run, dy over dx, and then return the length of slope. So however many, for each slope, I can see exactly one of them. And def parse raw, which is a string, and that's going to return asteroids. And what I want to do is for y line in enumerate raw dot split raw dot strip dot split on new lines, and then for x c in enumerate line. So now I can put this, I'll just do list comprehension like this. And if C equals pound, and I just want to return asteroid XY, like that. So run d10.py, that works. And raw is this. Asteroids equals parse raw. So let's look at so it's saying x equals 1, y equals 0, x equals 4, y equals 0, 0. Okay, so that looks good. And for asteroid in asteroid, let's just, for asteroid in asteroids, print asteroid count visible asteroids. So this will check if my logic is right. Division by, because I should have done dx equals 0. So this is saying 7, 7, 6, x equals 1, y equals 2. That's also 6. So it gets the right answer, but it gets a bunch of wrong answers too. So why does it get wrong answers? It gets wrong answers because dx dy slopes. So 7, 7, 6. So let's look at 0, 2. And that's doing 6. And so it's saying 0 up minus 2 over. So that's this guy, infinity. 3 up, yep. That. So he should be able to see 1, 2, 3, 4, 5, 6. So why could this guy see 7? He can see 1, 2, 3, 4, 5, 6, 7. That's correct. So because I need to keep track of directions as well. So let me fix this. And it's not just the slope, it is so let me try GCD 3, 4, math.gcd of minus 3, minus 4 is also 1. Math.gcd 3, 0 is 3. Math.gcd 0, 0 is 0. Okay, so what I want to do, what is that? Port math. Okay, so now instead, what I want to do is I want to do GCD equals math dot GCD of dx and dy, and then dx, otherwise if dx equals 0, slopes dot add 0 comma dy over okay, actually this should be okay, I think. Else slopes dot add dx divided by GCD dy divided by GCD, so that this will Okay, 776777587. So okay, so let me do a tuple def best station asteroids, which are asteroids, and that's going to be a tuple of an asteroid and an int. And what I want to do is result equals, let's say, a count visible asteroids A for A and asteroids, and then return max results key equals lambda pair 1. Okay, and so now what I want to do is just say print best station for asteroids, and now let's run it, and it's the guy at 3.4. So let me say assert best station asteroids equals asteroid 3.4 with 8. So best station asteroids. Okay, so let's try raw 2 is this guy, and rather than doing that, let's say A2 equals parse that, assert best station A2 equals asteroid 5833. So that looks good. And I'll just add this one more before I won't do all the unit tests. A3 equals parse this, assert best station A3 equals asteroid 1113 and 210. So let's run that, and that works. Okay, so now let's look at this, and I'll just hard code it again. Raw equals this, and I don't even want raw. I'll just say asteroids equals parse this, print best station asteroids, and that says that I can see 319. So let's go here and say 319. That's right. 1 gold star. Continue to part 2. Okay, once you get the coordinates, else quickly define inset monitoring station. And there are simply too many asteroids. The only solution is complete vaporization by giant laser. Fortunately, in addition to asteroid scanner, the monitoring station also has a giant rotating power for the air starts by pointing up and always rotates clockwise every time the asteroid hits. If multiple asteroids are exactly on its station, the laser only has enough power to vaporize one of them before continuing its rotation. In other words, the same asteroids that can be detected can be vaporized, but if vaporizing one asteroid makes another detectable, newly detected asteroid won't be vaporized until the laser has returned to the same position by rotating a full 360 degrees. For example, consider the following map, blah, blah, blah. The first 9 asteroids that get vaporized in order would be this, finally. This large example above, the one with the best monitoring station, is that, which will be the 200th asteroid to be vaporized. Win the bet by determining which asteroid that will be. What do you get? So we need to basically iterate over the asteroids. So let's say iterate asteroids, and that's going to give us an iterator over asteroid, and we'll just and for starters, let's do so so I'm basically probably just going to copy this logic again. And station, which is an asteroid, and we're going to do that. So what I'm going to do is I'm going to say, and let's do from collections import default dict, and so what I want to do is I want to say asteroids by angle is a default dict of list, and then for x, y, and asteroids, dx equals x minus station blah, 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 GCD. Otherwise, let's say angle equals dx divided by GCD, dy divided by GCD, and let's say asteroids by angle dot append asteroid. Okay. Append XY. And actually, what I want to do, yeah, that's fine. And so now, what do I want to do? I want to a couple things. Sort by length. I want to say ascending, no, descending, because I want to pop off the end for each angle. So for angle asteroids in asteroids by angle dot values, angle asteroids dot sort, key equals lambda asteroid. What do I want? I guess if I do absolute of dx plus absolute of dy, and they're all in this absolute of x minus station dot x plus absolute of y minus station dot y. So I sort those by length descending. So I want to do reverse equals true. So I do that. And now I need to do the rotation. The laser starts by pointing up, and always rotates clockwise. And here's what I want to do. While asteroids by angle, keys equals asteroids by angle dot keys, and this is going to look like dx and dy, and so I want to sort by angle, and def angle dx, which is an int, and dy, which is an int, and that's going to go to a float. So let's think about how to do this. And so, if dx equals 0 and dy is greater than 0, I'm going to do this. Elif, and I'm going to do a little bit of cheating. Not cheating, but so I'm just going to do some some tuple sorting. Otherwise, if dx is bigger than 0, and actually, when I say, I think that's actually it. Dx and dy is less than 0. Return 1, comma, and so I want, dy is -1, and so let's say I go up here, let's say I go way over here, then dy is going to be very small. E.g. 0, -1, straight up. E.g., 0, let's say 0.1, and, -0.9, or 0.9 and -0.1. Then what I want to do is I want this one to be first. So I want to do dx divided by abs dy. Otherwise, if dx is bigger than 0 and dy equals 0, I'm just going to return to 0. Elif dx is bigger than 0 and dy is bigger than 0, e.g. 0.9, 0.1, or 0.1, 0.9. This is such a clunky way to do this, so I apologize. I want to return 3, and again, I want this one to come first, so I want I don't want dx over dy, I want dy over dx. Otherwise, I've got to be screwing this up somehow. Dx equals 0 and dy is bigger than 0. Return 4, 0. Otherwise, dx is less than 0 and dy is greater than 0. E.g., negative 0.1, 0.9, or negative 0.9, 0.1, and I want this one to come first, so I want dx divided by return 5 abs dx divided by dy. Otherwise, if dx is less than 0 and dy equals 0, return 6, 0. Otherwise, dx is less than 0 and dy is less than 0. E.g., so the first one there is going to be negative 0.9, negative 0.1, or the last one there is going to be like negative 0.1, negative 0.9. So I'm going to return 7 and so I went this one first, so I went dy over dx. And I could do abs on both, but I'm negative. And so that should be fine, I think. Keys equals asteroids by angle dot keys. Keys equals sorted keys. Key equals angle. So I'm going to sort them by angle. For key in keys. And what I want to do is angle asteroids equals asteroids by angle key. Yield angle asteroids dot pop. So that's the closest one. If not angle asteroids. So if it's empty, now I'm going to say delete asteroids by angle key. And let me for example, okay, so let's say we're redefining raw, but that's okay. And let's say new asteroids equals parse new station equals best station new asteroids 0. New station is 4, so asteroid with the new monitoring station. Actually, that's not what I want. New asteroids is this, and I want it to be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 8, 3. Is that one of them I have here? X equals 8, y equals 3. No, I don't even have that. So let's try that again. 0, 1, 2, 3. Because he called him X. Now I should have 8, 3, right? 8, 3, yes. So new station equals asteroid 8, 3. Print list iterate new asteroids new station. So let's run this and see what happens. tuple object is not callable. Sorted keys key equals angle because let's say faux angle. It's not really an angle, but it should suffice to be one for sorting purposes. Faux angle is missing. Is that true? Yeah. So it's saying that the ones I get are 8, 1, 9, 0, 9, 1, 10, 0, 9, 2, 11, 1, 12, 1, 11, 2, 15, 1, 12, 2, 13, 2, 14, 2, 15, 2, 14, 3, the large example above. So something's not going right, but it was very close. 1, 2, 3, 4, 5, 6, 7, 8, 9, 15, 1. So that's good. And now let's go to 12, 2, 12, 2, 13, 2, 14, 2, 15, 2. And now why does it do 14, 3 and not 13, 3? Something along the lines of, let me print asteroids by angle, because it's something to do with that that 12, 3 is where is 12, 3? It's at 102.0. And why is that it's not getting sorted correctly? Why is it not getting sorted correctly? Key equals lambda a, absolute x minus station x, reverse equals true. So, because this is a dot x and this should be a dot y. And now let's run it again. Angle asteroids append asteroids by angle append asteroid xy. So that seems to have fixed that, I think. I think that was just a bug. And now let's not print asteroids by angle, and let's run it. And now for asteroid in iterate this, print asteroid. And so now, now I think it's pretty good. 8-1, 9-0, 9-1, 10-0, 9-2, 11-1, 12-1, 11-2, 15-1, and then 12-2, 13-2, 14-2, 15-2, 12-3, 16-4, 15-4, 10-4, 4-4, 2-4, 2-3, 0-2-1. Yeah, so that looks pretty good. And so now, okay, so vaporizations equals list of iterate of and so station equals best station of asteroids 0, list iterate asteroids station, print vaporizations, the 200th asteroids. So that should be vaporization 199, right? So multiply its x by 100 and then add its y coordinate, that would be 517. And let me make sure if I want vaporization 0 would be the first. So here's 199 would be the, that's the right answer. Hey, I got some points by getting on the leaderboard. That's pretty cool. That's the first time I've done that this year. So yeah. All right. So that's good that it worked. And as always, I have not been paying any attention to the streaming people. So anyway, 45 minutes, that's too long, but yeah. Anyway, I'm glad that it worked, and maybe I'll do this again tomorrow. Maybe I won't, because I'm traveling and it's difficult. But yes, that's all. Thanks for watching.